So this is Ashish Jadhav, working in Department of Electronics and Telecommunication Engineering, Sweris College of Engineering, Pandharpur. So before we move on to the next part of vector algebra, let us recap basic concepts of a scalar and vector in short, and then we will proceed for understanding vector algebra. So basically, there are two kinds of quantities. One is scalar, second is vector. So scalar quantity is being represented by only a magnitude. So examples are like temperature, mass, volume and energy, density, pressure and voltage. Whereas vector quantity is nothing but a quantity which is described by magnitude and the direction of that quantity. So examples of vector quantities are velocity, force, acceleration, etc. So the definition of vector is equal to magnitude into direction. So notation of vector quantity is boldface letter, or you can simply put a capital letter and a bar on the top of that letter. So for example, here force is represented by F bar, and velocity is represented as V bar, right? So here is the vector representation, which will have a starting point, end point. So this vector, let's say starting point is A, end point is B. In that case, the vector is represented by AB bar. So this magnitude, this vector AB bar is given by a magnitude, that is AB, multiplied by direction A bar AB. This is nothing but unit vector in the direction of AB bar. And mod of AB is nothing but magnitude of that vector. So next is unit vector. So this is the definition of unit vector. Unit vector A bar AB is equal to AB bar upon mod of AB. That is nothing but vector upon magnitude. And in short, for the example of representation of vector, which consists of point A represented by x1, y1 and z1, and point B represented by x2, y2 and z2. These are the coordinates mentioned in Cartesian coordinate system. So in that case, vector AB bar is equal to x2 minus x1 a bar x plus y2 minus y1 a bar y plus z2 minus z1 a bar z. And the magnitude mod of AB bar, or simply AB, is given by under root x2 minus x1 bracket square plus y2 minus y1 bracket square plus z2 minus z1 bracket square. So here is one of the example to solve. Find PQ bar if point P is given as a 2, 1, 3 and point Q is minus 2, minus 4 and 5. So these 2 points are mentioned in a Cartesian coordinate system. So to find this vector unit, to find this unit vector, we need to find out the vector first. So PQ bar is equal to x2 minus x1 a bar x plus y2 minus y1 a bar y plus z2 minus z1 a bar z. This is the definition of vector, right? So by putting the values minus 2 a bar x plus into bracket minus 4 minus 1 a bar y plus 5 minus 3 a bar z. So if you calculate this, you will find PQ bar is equal to minus 4 a bar x minus 5 a bar y plus 2 a bar z, and unit vector of PQ is a bar PQ, which is equal to PQ bar upon mod of PQ. So simply by putting the values minus 4 a bar x minus 5 a bar y plus 2 a bar z divided by under root minus 4 bracket square plus minus 5 bracket square plus 2 square. So final answer of this is a bar PQ is equal to minus 4 a bar x minus 5 a bar y plus 2 a bar z divided by under root 45. So today we are going to discuss about the different operations. As we know, the vector addition and subtraction is possible with the help of doing respective operation between the coordinates x coordinate, y coordinate and z coordinate. So directly we will move on to the product of vectors. There are two categories of taking product of vectors. So first one is scalar, or we can call it as a dot product, and second one is a vector or cross product. So let's begin with the dot product. Dot product is, let me define it first. Dot product of two vectors is nothing but the product. It results in a vector uh, which is equal to uh, product of their magnitudes multiplied by cosine of angle between them. So simply, if we take two vectors, that is a and b, vector a is equal to a bar a, and b bar is equal to b a bar b. These are the two vectors. They are making theta angle with each other. In that case, a bar dot b bar is equal to ab cos theta, where a is magnitude of a bar, b is magnitude of b bar, and theta is angle between a bar and b bar. Now there are three different cases we must understand. First one is if vector a bar and b bar are parallel. In that case, theta is equal to 0. That means they are making they are making 0 degree angle with each other. So if the vectors are parallel, theta is equal to 0, cos theta is equal to 1, and hence a bar dot b bar is equal to ab. Second case is if a bar and b bar are perpendicular, that means theta is equal to 90 degree, that means cos theta is equal to 0, and hence a bar dot b bar is equal to 0. Next is a bar and b bar, if they are opposite, that means theta is equal to pi, that is 180. So cos 180 is equal to minus 1. In that case, a bar dot b bar is equal to minus ab. We also have understanding about the dot product between unit vectors. So let us take a dot product between unit vectors. So a bar x dot a bar x, that means self product we are considering. A bar x dot a bar x is equal to a bar y dot a bar y is equal to a bar z dot a bar z is equal to 1, because we are talking about the same vector. If you are taking multiplication of two vectors which are same, then in that case theta is equal to 0. If theta is 0, we know that it's just multiplication of magnitude of those two vectors, and magnitude of those unit vector is 1, hence the answer is 1. Next is the dot product between unit vectors. So a bar x dot a bar y is equal to a bar x dot a bar z is equal to a bar y dot a bar z is equal to 0. Reason is these vectors are perpendicular to each other. While taking dot product, we know that if theta is equal to 90 degree, then cos theta is 0, and hence the dot product results in 0. So answer is 0. Next is another definition of this dot product. If a bar is represented in a Cartesian coordinate system as a bar is equal to ax a bar x plus ay a bar y plus az a bar z, and b bar is represented as bx a bar x plus by a bar y plus bz a bar z, in that case a bar dot b bar is equal to ax bx plus ay by plus az bz. Next type of product is vector product, or we also call it as a cross product, represented by a cross sign. So let us again consider two vectors a bar and b bar. So as per the definition, this cross product of two vectors is the resultant which is equal to product of magnitudes of those two vectors multiplied by sine of angle between them, and the direction is represented by right-handed screw set. So here in the diagram you can observe a is the vector making angle theta with b vector. In that case, if I place the screw on the top of that plane and if I rotate in the direction of angle, then the screw will head towards top. It will head in upward direction. So a bar n will be the direction. So if I take a reverse multiplication, that means b bar cross a bar, in that case the direction will be negative. That means the screw will head in the downward direction, hence a bar n will change its sign. So in that case b bar cross a bar is equal to ab sin theta into minus a bar n, and in that sense we can verify this property, a bar cross b bar is equal to minus b bar cross a bar. Similar to the dot product, here are also some of the cases we must know, in which first is if a bar and b bar are parallel, in that case theta is equal to 0, sin theta is 0, hence a bar cross b bar is equal to 0. Second thing, the cross product of unit vectors. So here we must follow this triangle where a bar x, then a bar y and a bar z. If we follow the arrows, then it will give you positive results. If we don't follow the arrows, it will give you the negative result. That means a bar x cross a bar y is equal to a bar z. Then a bar y cross a bar z is equal to a bar x. Then a bar z cross a bar x is equal to a bar y. On the other hand, if you don't follow the convention of these arrows, you will get the negative answer. As I said, a bar y cross a bar y, x is equal to minus a bar z. Similarly, a bar z cross a bar y is equal to minus a bar x. Then a bar x cross a bar z is equal to minus a bar y. So here is another definition of a cross product. If I consider two vectors in a Cartesian coordinate system, a bar is equal to x, a bar x, plus a bar y, plus az, a bar z, and b bar is equal to bx, a bar x, plus by, a bar y, plus bz, a bar z. In that case, a bar cross b bar is equal to this a bar x, a bar y, a bar z, ax, ay, az, bx, by, bz. Now let us solve one example on this. Suppose we are having two vectors, a bar is equal to 2 a bar x plus 2 a bar y plus 0 a bar z, and b bar is equal to 3 a bar x plus 4 a bar y minus 2 a bar z. So one more thing, you should show that this a bar cross b bar is perpendicular to a. So for that, first of all, find out the cross product between a bar and b bar. So by using definition and putting the values, we get a bar cross b bar is equal to minus 4 a bar x plus 4 a bar y plus 2 a bar z. Next, to show those two vectors, that is a bar cross b bar and a bar perpendicular to each other, we need to find the dot product between them. If dot product results in 0, that means these two vectors are perpendicular to each other. So let us find out the dot product. For that, we have the expression, if those two vectors are a bar and b bar, then in that case ax bx plus ay by plus az bz is the formula. So same formula we are using it here, minus 4 into 2 plus 4 into 2 plus 2 into 0. So this will result in 0, hence those two vectors are perpendicular to each other. Let us solve one more example. If vector a bar is equal to 3 a bar x plus 4 a bar y plus a bar z, and second vector is b bar. B bar is 2 a bar y minus 5 a bar z. So to find the angle between a bar and b bar by using dot product. So to obtain the angle between those two vectors by using dot product, you must find out the magnitude of those two vectors first, because as per the definition we require the magnitude. If we know the magnitude, if we know the dot product, you can easily find out theta, right? So a magnitude is calculated here for a bar. It is under root 26, and it is under root 29 for b bar. Then we can find out a bar dot b bar, which is equal to ab cos theta, which is equal to 3 into 0 plus 4 into 2 plus 1 into minus 5. So the answer is 3. So finally we can write 3 is equal to under root 26 multiplied by under root 29 multiplied by cos theta. From this, cos theta is equal to 0.1093. That means theta is equal to 83.73. So same can be calculated with the help of cross product also. So this example you can consider for homework. Find out the smaller angle between those two vectors by using cross product, and verify that in both the cases, that is in case of dot product as well as in a case of cross product, you get the same answer. So this is the end of this video. In the next video, we will see different coordinate systems such as Cartesian coordinate system, cylindrical coordinate system, and spherical coordinate system, along with their different parameters, how they are represented, how they relates each other, how we can transform the point mentioned in a spherical into a Cartesian, or if the point is mentioned in a Cartesian, how it can be transformed into a cylindrical. So those interrelationships we will discuss in the next video.